Hey y'all, I'm Daniel and this is Wilbur.
I'm Wilbur.
And sorry.
All right, yeah.
Hey, so we're both engineers here at Leap Motion. I've been working a bunch on a lot of our operating system control work for our version 2. So if you've played with shortcuts at all, I've been working a bunch on that. And Wilbur's been working on some really cool VR stuff.
Yes, I'm another software engineer at Leap Motion. I'm working on mainly on Unity, VR, demos, etc., the assets that you'll soon see.
So yeah, we're what we want to do today is we know a lot of you are working on stuff for the 3D Jam, and a lot of you have been really interested in virtual reality, especially with Unity. So we wanted to take a chance today to show you how to set up a project for Leap Motion with the Oculus. If you've for those of you who haven't seen it before, you can get a mount for the Oculus Rift that will let you mount your Leap Motion on the front of the Rift. And so we're going to take you through a bit of how to set up a project, and then how we've been designing some new interface elements and that sort of thing with VR in mind. So with that, I suppose we can start looking at where to go get all the assets for that for setting up a Unity project.
All right, so this is the Leap Motion website. To get the VR assets, you want to go to Devs. And then under Downloads, there's Unity-C Sharp. And then you'll see the V2 core, and you'll see Leap Motion VR. We supply both Unity Pro and Unity Free versions of the plugins required to do Leap Motion with Oculus on Unity. The Unity Free right now only works on Windows. We are working on solutions on getting to work on the Mac. And so I guess we'll just show them straight to the thing.
Yeah, so we're going to be using Unity Pro today, but once you've downloaded the Unity Free version and opened up the project, it'll basically be the exact same process. So I guess we can. So if you want to follow along, you can go download all that right now. So I guess we'll switch over into Unity here. Cool.
All right, so I'm going to start from a completely new project. And I'm going to be using Unity Pro. Okay, so it's hard, you can't see it on the screen, but I'm going to import the asset, the Unity Pro asset that was shown on the website right now.
So that's coming over the line. While we're kind of getting all this set up, I definitely saw a few questions coming in about kind of design for VR gestures, especially precision. That's definitely something we can get into and cover in a little more detail. There was a question about using 2 leaps at once. That's something that we're playing with a lot internally, and as soon as we have something that's reasonable to show to the outside world, we'll definitely kick that to the developer community. So keep an eye out on all of our our developer blogs and our Twitter and that sort of thing, and you'll hear about that as soon as we're ready to show something. Precision we can definitely get into a little later when we can show some of the work that Wilbur's been working on. With the Unreal Engine 4 plugin, there isn't an official plugin right now, but I know there's a lot of interest in that, so that's probably something that we're going to be looking at in the future.
Okay, so the Unity assets have been imported, and to set it up, you go to Leap Motion plus VR folder, and there'll be a prefab called Leap Motion VR Player Controller. This prefab, just drag it in, and it has everything included already, including the Oculus and the hand controller in the center eye anchor.
Right. So if you watched what Matt and I showed last week, that hand controller is kind of the basis for all of the hand-based interactions in the scene. You can think of it as the virtual representation of the Leap Motion controller itself. So in this case, it's been connected to that Oculus VR camera, so that as you move your head and all that moves around, that'll all track and keep your hands in the right place.
Yeah, I'm going to remove the main camera because it won't be needed for this purpose. So just to show you a very basic version of it working, I'm just going to add some light and make sure. I'm going to disable the pass-through for now. I'll show you that in a bit. One thing to be aware is that the player controller has gravity, so if you don't have a plane underneath it, it would just fall infinitely into another world. So make sure you set the gravity to either 0 or you put a plane underneath it. Alright, let's see how this looks. So I'm just gonna preview the play. And there you go. You see the hand on the game scene there. Awesome. It will look the same as you would put onto the runtime mode. So what's one new thing that we added to the VR recently is the VIDA pass-through. There are 2 quads for each left and right eye. They are quads used to render the texture that's used for the pass-through. So I'm just going to enable both of them. And as I run, you can see it's pass-through. Hello, Daniel. Yeah, so that's the very basics of getting it running. It's very easy. Just drag the Leap OVR player controller, which is under the Leap Motion plus VR scene folder, into the scene, and that's all it is to get it started. Very seamlessly easy. Okay, so I guess I'll show you something you can do with the new VR assets. I'm gonna make a very simple button, and let's see where we can go from there.
Okay, so one thing they're saying is that they're having a little trouble seeing what's going on in Unity here. So maybe let's see if we can scale down the Unity window and then let's reset this. Let's reset the way we're handling that stream. Though you'll want to keep it. If you go back to Unity real quick.
Sure.
Want that aspect ratio a little further out, so we can just like bring in the corner. Advance it real quick. Sorry, folks. Get that fixed real quick.
Is that good enough?
Yeah, let's try that, and then let's re-add the scene over here. Pardon the minor technical difficulty. Yeah, that should work. Awesome. And then we'll scale that up to be the full size. Nope. Nope, not edit scene. Pardon me.
Pardon me.
And then flip that over. Awesome. And we should be good. Okay, that should be better. Let us know if that looks a little bit better for y'all.
Okay. Okay, sure. I guess I'll just go through it real quick again, in case for those that missed it because of the resolution issues. So I'm gonna remove everything here. Let's see here. So the original setup is you have a main camera as an empty project, and inside the Leap Motion, let me just drag this over here. Oopsies, that didn't work as I wanted. Under the Leap Motion plus VR, that is the folder that is included within the Leap Motion VR assets. Within this folder, you'll see that there is a Leap OVR player controller. This is a prefab that has both the Oculus and the Leap Motion hand controller inside it. The hand controller is covered by Matt and Daniel last week. You just drag it into the scene, delete the old camera, add some lights. Directional light. Make sure the gravity is 0, otherwise the Leap Motion player controller will just keep falling. And play. And voila, there you go. You have the pass-through and you have the hands.
Cool.
So yeah, I'll show you really quick on something that I've been working on. And one thing I was working on is how to make 3D UI, I guess you can call them widgets. One of them is a button. So let's start with that.
And just to throw this out there, so everything that we're going to be showing here, we're going to relatively soon, probably by either end of this week, early next week, we're hoping to share all of this with all of you. So we don't have it quite out yet, but soon you'll be able to download this project and play with this yourself and mod it and use it however you'd like. So as we're going through that, keep that in mind. If there's things you're going to want to build with this, those will all be public info.
Okay, so I'm just gonna create a basic script, and let's call this a button script. Okay, let me switch to model develop here. So originally for the button, so the general idea of how I want it to work is as you press into the button and you let go, you want to spring back, have like a physical feel of the button. And at first I was using Unity's spring joint. I found out later on that spring joint has a really weird characteristic where it doesn't fully go back to resting position. Let me just show you quickly on what I mean. Let me just go back to Unity and show you. Okay, so let's just say for a very basic, without script based kind of button, how it will look like. So I have a spring joint, and I have a rigid body, box collider, and a spring joint. Let's just set the spring to very high, no dampening. You want to make sure to set the distance to both 0 so it works all the time. And let's just add some drag. And that should be it. So, okay, let's add some cube to this. Okay.
And so you're
Yeah.
making the cube a child of the button itself.
Yeah, so the way I tend to do it is I make the graphics separate from the physics. This way it's easier to change the graphics as opposed to having the graphics linked with the physics in one game object. I find it easier to coordinate when they're separate game objects.
And so, in terms of the button, you're actually going to be pressing in the physical collider with your hand?
That's right. So right here, this is the model I want to show you without using any scripts at all. Make sure to scale it down though. Keep in mind, all the units we're using with the hand controller is every one Unity unit is 1 meter. So every object you have, make sure to scale it down. So right now, this cube is effectively a 1 meter cube. Let's make this a little smaller. Let's just do maybe 5 centimeters, or maybe it's too small. Let's do 10 centimeters.
So that'd be 10 centimeters.
Yeah. Let's make the distance, let's just say 50 centimeters away. There you go. You see it there. So let's run this. And, right. One small thing. The player controller has a height of approximately 0.75. It's the height of the player controller. You can set that yourself, but by default it's 1 meters tall, and then the camera is, I think, is a ratio of maybe 3/4 of that. So to make it directly in front, make sure to position the object around that height. So you see it there. You see my hand, and then, oops, there you go. So this is a spring there. It just goes back to the original spot. And you can make it appear better by, let's disable the constraints.
And you're setting those constraints on the rigid body,
Yeah.
so it can only move, it can rotate in no axis, and it can only translate in the z-axis.
Yeah, that's right. So here, so there, it feels like a real physical button now. But there is one issue, is that, let's take a quick look at the button. Okay, so, oh, it's hard to see the spring. Okay, let me do something real quick here.
All right, so you've got now
what I'm doing right here is I'm going to create a child of game object so you can see the original position of the location before it being moved. Okay.
So you've got a box collider.
Yeah. So here you see that the button is a child of the game object. The reason why I'm showing you this is because Oopsies. Let me just put that over here. So even when I push a little bit, you can see that it's actually off. It's an offset. I stop pushing it and it'll come back. It will not come back to resting position if you push it very lightly. If you push it hard, it does. Even then, it's not perfect. So this causes a weird problem where if you have a very, very sensitive button, this weird offset will cause the button to not ever go back to resting positions and ending up triggering all the time if it's just going the right distance to trigger whatever it is you want to trigger. Because of this, I had to kind of implement the spring equation into the script to make it work the way I want it to work. So let's go back to the script.
So we probably want to do the same resolution trick we did with Unity to Mono here, just so it's a little more legible for folks.
Sounds good.
That's a C assembly C#. Scale it up and flip the webcam. There we go.
Okay, awesome. So the basic spring equation, let me just grab that real quick.
Yeah, that's better. So we're just going and grabbing a
Yeah.
copy of this script real quick just so we can make sure we show you the right thing.
Yeah, that'd be very important. Okay, so the spring equation is, let's call this, let's see, protected void apply spring, and let's just say rigid body dot add relative force negative.
And what does the relative force one do?
So yeah, so there's two functions: add force and relative force. Force is a global force. Relative force is a local force. It's relative to the local position. The reason why I use relative force is because when I design the button, I'm doing all in local space, and I have it in the Z depth, the Z depth. And yeah, sorry, there was a Canadian slip there. I use the local space. The reason why I use local space because it's a lot easier to track in one axis as opposed to, you have to figure out what direction it's supposed to be in, all that kind of stuff. So for rotations, I have the button child of a game object and rotate the parent and have the child operating all in local space. I just found that a lot easier to do.
Nice.
Yeah. So let's just have a public float string like the spring join has, and in here we have negative spring times the transform local position minus, let's just call it resting position, and we'll have a private vector3.
So it's the spring
resting
force times the
position.
difference between the rest position and its current position.
That's right. It's a very basic spring equation. So at the start, we set the resting position, and then it will always try to add a force back towards it. And then every update, we will have a apply spring. Okay, so for this one, as you can tell, there is no constraints. So when we go back, it will function the same way before I add the constraints. Let's remove the spring joint, and let's add our new button script into it. Let's just add the spring is 100 before, we'll keep it 100 now, and let's try it out. So this is without constraints, so it might fly around a lot. Oh, maybe it won't. Oh wait, the constraint is there. There you go. Oh, there it goes flying. Whoops.
And that's where we have constraints.
Yeah, there's other constraints. The cube itself has box collider. Oh, that's why. Okay, it was colliding with itself. My bad. Okay, now I shouldn't do that anymore. Okay.
And so what was the mistake with the box
Yeah,
collider there?
the mistake was that when I added the cube had a collider, and the hand itself was a collider. It kind of got stuck to the hand there. The game object itself has. That's the trigger though. That should not have happened. Okay, but yeah. Either way, it's we have to remove that. Let's take a quick look at why it was flying around crazy. If we had the constraints.
Oh, they can't see
Yeah.
your Unity right now.
Oh, whoops.
Sorry.
Very sorry. Okay. Let's do this again. Whoopsies. So let's play this. So yeah, right now I removed the spring joint. I added the button script we have with a very basic spring equation. And let's start this. And whoop. So let's take a quick look. So before, remember, we had the problem where as you push it, it will not go back to resting position. Because I think Unity has some check. If it's close enough to the anchor, it will stop moving. But for this one, because we don't have any checks like that, it will always go back to resting position. This allows you to have a more sensitive button. You may want to add your own dampening of sorts, but I found this is a lot more, I guess, predictable than, because yeah, when you have working like very small scales, 0.1, 0.05, when you're working in centimeters, Unity has some checks where if it gets close enough, it will do that kind of stuff. So unfortunately, we can't. We had to use our own script for that.
Right.
Okay.
So do we want to look into setting this up so it actually triggers an event when you press the button?
Sure. Okay. So for that, let's just say we'll float and trigger distance, for example. Let's go back to mono. So here I added a trigger distance as a public, and this will, I guess, we'll use that to determine how far it is to trigger something. And we will have a private void and because we always need local space, and we're gonna use the z-axis for this. So we'll do if the transformed local position dot z is greater than the trigger distance, then we will, let's just say, we'll print out I love VR. All right, let's go back to Unity and see this in action. Okay. So in the button, we should have distance, and let's just say the distance is maybe just 1. Okay.
So they have to move it essentially a
Yeah.
meter.
It's
Or is it scaled?
It's a local space.
Oh, so it'll be scaled by
it's-
the original amount.
Yeah, it'll scale on its own. So, I love VR. Yay, it's working. There's one thing. Obviously, you want to sometimes you want a button that. Okay, so you see the spring thing, right? Sometimes if you don't want a spring like that, you can add additional constraint so it doesn't bounce forward. Let's go back to model, and I'll show you how to do that. One way you can do that is, let's just say check void constraint movement, and you can do vector 3 local position equals transform let's just have two. Let's do two, both minimum and maximum. and the end here. Before we apply the string, we will check constraint first. Okay, let's go back to Unity. And this should fix the spring problem we had before. This is not required with dampening. The reason why this works without dampening is because the minute it hits the resting position and tries to go over, the constraint will kick in and it will just move it back to resting position. So let's try this again. Oopsies. Must have missed something here. Oh, max distance 0, of course. Max distance, let's just say 1 as well because of trigger distance. I said 1.1. And with this, now you have a button that doesn't that look cool? So if you push far enough, you still get the I love VR as we had before. There is one issue with this is what if you want a button that just gets triggered when it's pushed, but you don't want it to be called indefinitely when it's triggered. So you want to be where when it's hit, it only gets triggered once, let go, hit, trigger a second time. You don't want to, when it's hit, it triggers indefinitely. To do that, you need to have a check. Let's go back to Mono. So I'm gonna do a very primitive way of checking. I just have a boolean is pressed, and let's initiate is pressed to false, and we will in check trigger if it's greater if pressed then debug. I really love VR is press equals false equals true. Sorry, this is equals false. And else if transformed or local position less than trigger distance. Let's just say the motion is awesome. Is pressed equals false. Okay. So here, the logic behind this is that I check the trigger every time. If the trigger is not pressed yet, then I will check if it's greater than the distance. If it's greater, then it's pressed and set to true, so it won't be ran again. On the other hand, if it is pressed and if I leave or if I get smaller than the trigger distance, then I will set it back to is pressed to false and trigger an event. Printing out the motion is awesome. Okay, let's go back to to Unity. Cool.
So do we want to grab some of the more finished stuff and kind of show what this looks like once you start to add a bunch of the extra polish and that sort of thing?
Yeah, for sure. Let me show you this real quick. And so I press it in. Oopsies. I really love VR. Let go. The emotion is awesome. I really love VR. The emotion is awesome. Okay. So this is kind of the basic frameworks that we started with working on this, and now we're going to show you something that we have finished or soon to be finished and hopefully give to you guys. Let's close this. Let's see here. Okay. So I guess we'll just show you the app, the full application in itself. Please give me a second here, guys. So we've been working on some widgets on trying to find a good UI paradigm of using VR interaction. So let me just show you something that we have been working on. Oh, this is all tangled up. All tangled up. All right.
Too many cables.
Yeah, I know. Alright, so this is really similar to the button that I showed you before. It has a spring action as before, and you can tell there's a little bit of layer on it. So I can press it in a little bit, and it'll trigger on and off. At the same time, we have a slider here that also has the same spring, and you can hold onto it and move sideways. These are some of the UI things that we're trying to work on. And it has been proving very pretty and very nice. So other than the buttons and the sliders, we also worked on scroll. So on over here, you can imagine you have a lot of content, and you can go through these. So they all follow the same logic as a button. This one also has a spring to itself. Instead of having to just constrain on the Z, some of these have constraints on different axes. For example, the slider has constraint only just the Y. The scroll only has constraint on the X. And there's other little, detectors we put inside to follow the hand. I'll show you how to follow the hand in a bit on how do I do this kind of stuff. So yeah, there's that. Oopsies,
Getting pretty.
And here's another one, a big version of it. This one, I can actually read the text, and so you can imagine this being a Twitter feed or a blog post. It would be very cool to read in VR.
So did these designs change
Yeah.
at all while you all were working on them? Like from what you kind of originally conceived, did anything evolve as you were going?
Yeah, so the original design we have it was nothing as cool as this. We were at the very beginning, I was using the spring joint, and that caused a lot of problems because of I mentioned about we're working in such small scale that we had to end up using the original spring equation. And the slider, we also used to have a physical button where you move it side to side. That was a little bit tough because if you move too fast, you can actually go past the collider and then it won't work the way you want it to work. We found out the whole Iron Man experience where you press in and you move sideways is a lot better to a lot of people.
Nice.
So with that, we borrowed the button logic and applied it to everything. The scroll, the sliders, and then we're hoping to do something else in the future as well.
And how did you all, while you were developing, what did you do to test that? Like how did you kind of test your assumptions and figure out what needed to change?
Right. So for this one, we don't have user test for this. I guess we can call it widget 2.0. We had an original version, which is 1.0, using a lot of physical objects to do. We had user tests for that, and it was pretty good. But this one, internal people that we'd have people tried, they like this one a lot more. So we hope to put this into user test really soon and let you guys know at what scale is it reliable to be used and what sizes, all that kind of stuff.
Right.
Yeah.
What is the just in your own experience? I know there were some questions early on about precision. What is have you all tried to see like how small you can, like just in your own kind of untested experience, what works and what doesn't?
Right. So the size I have right now, I find is just the right amount. If you're to how small you can really go, I don't think you can go smaller than 50% of the size you see now. It's pointing fingers and pressing it straight on is a tough thing for us to detect right now. If you can have something that's big enough where the users use kind of multiple fingers, like 3 fingers for example, to touch into it. So in this case, if you have a whole hand to, it's reflection over there. Yeah, so having a whole hand like this to touch it is a lot better. And
And so that's actually something worth mentioning, because I know I was talking with one of the other folks on your team, and they were talking about how as you were making the interface elements smaller and smaller and smaller, people went from trying to use their whole hand to interact to trying to use a pointer. And what you'll notice when you look at the tracking is right now there's a lot that the camera can see. You can see in the pass-through how much of my hand is visible. And the more of the hand that's visible and the more portions of the hand that's visible, the better our tracking works. And so if I've got an open hand and I'm trying to interact with that full hand, that track is going to be really solid. But the moment I reduce that and start pointing, especially if I start pointing straight ahead, you can see how the finger gets occluded by the rest of the hand, and it becomes a little less accurate. You can see that the hand seems to rotate a little and jump around a little more. And so anything you can do and you can see it can cause some issues occasionally. So anything you can do in your user interface design to keep the hand open and to keep as much of the surface area in your gesture design visible, the better. So larger interface elements, people are going to naturally want to interact with them with the full hand, whereas smaller ones, people are going to try and kind of naturally interact this way. And it kind of comes back to keeping simplicity in your designs, not trying to overdo anything.
Yeah, so one thing that I want to mention as well regarding the hand positions, there's two positions we found having most reliable. One, having you design your UI so the oculus is facing downwards a little bit. This people will have more tendency to have like straight out and do this. You can do this for sure. You can see the whole finger, the whole hand. This is nice. Or you can have the UI at the top where they have to get up and touch it. This is not as comfortable, but having it straight is the toughest one because people have the tendency to go outwards, and when you go out, your whole palm can block the fingers, and then it becomes hard for us to see. But yeah, looking downwards, we can see the whole hand, or upwards, we'd have to reach up. Other gestures, you can see the whole hand reliably, and we can track that quite nicely.
Yep. Cool. So I noticed some questions rolling in. Is there anything about these kind of more finished assets that anyone has some questions about?
Yeah, so regarding the question, I see that, would it be on GitHub? Would it be available online? Yes, we do plan on releasing this to you guys either the end of the week or early next week. This is almost finished for you guys to use, and I'm really excited to see what you all can build.
Yeah, and of course we're always looking for feedback and that sort of thing as well. So the more you can kind of let us know what works, what doesn't, what's easy to use, what isn't. That's hugely helpful to us. So that's a big thing. What else what else is good to talk about here?
Let's see. One thing I want to mention. So the thing is, when you have a very basic push mechanism, you can have a really good, I guess, illusion that many different gestures work. When you have something very physical, like try not to restrain yourself to gestures, but rather physical objects. The reason why I say this is because people can try to pinch this, like right here, and even when they pinch, like it can still work. It's not because pinching works, but rather the physical object is being pushed back a lot, making it seem like pinching works. So if you make objects as physical as possible, it really makes sure it has a physical representation of how the users might play with it, and it covers more potential unforeseen gestures that you might not think about.
So there was a question here about how well can you make a UI correspond to a position in actual world space? So like right now, when you move forward and backward, the UI kind of stays where it is. Do you have this attached directly to the Oculus itself, or how have you set this up in Unity?
So no, all these is all in world space. These are all 3D objects. None of these are GUI or UI.
Okay.
The reason why it looks like I'm not moving is because I don't have position tracking on.
Right, we don't have the positional tracker camera set up. So if we had that, it would match a lot better. But if you've seen applications that use the positional tracker, there are times when the positional tracker does lose that track, and so at that point it'll shift out of your like real world space. But it does track pretty well in the Oculus space.
Yep.
Another question was, how sensitive is this to eye relief? Are you talking about? You're referring.
Are you referring to reading the UI? It's fine. It's as if you're looking at an object 3D space. So how it works is all these items are positioned approximately 60 centimeters away. So that means at my arm's length is roughly over here. To you, it would look like you have an object over here in the goggles.
Yeah.
It looks just fine to me. I didn't have any
So if you've
stress
been
looking at them.
So for those of you, I just saw a few people mention it, so I figured this is a reasonable reference. For those who have been playing with Elite Dangerous, I know at least for me when I'm playing, especially with my glasses on, I always have some trouble with the geometry.
Geometry.
I don't follow on that, but in terms of text, just to finish up the text legibility, the thing that I run into is a lot of legibility issues with different text menus and that sort of thing, which I know they're working hard on. In this case, with the font sizes that are in here, it all is really legible, even up to the sides of the view.
Yeah, so the font sizes, it's tough because the lenses themselves have distortions and it's hard to get the right focus. The one you see right here that I'm showing, this one I can read very clearly on the Oculus. The one over here, I had to squint my eyes, but I can still read it if I really try to. I mean, I will package this. This will all the demos will be included. You can see the font sizes that I'm using for this demo, so you can definitely piggyback off of this. I guess the sweet numbers that I found.
Yeah. So those, I mean, and the text, and you can kind of experiment with the text legibility yourself. The font that's here is also relative, like it's a nice bold font with some good spacing, and it's relatively legible. So that's good too. And in terms of the tools that we're using, everything we're using here is all public tools. We don't have anything directly from Oculus. At least nothing that I'm aware of.
I'm not aware of either.
Yeah, so we're using all public stuff, and everything that we release to you is going to be usable. Eye relief pulls out every time I have to. Last Yeah, the little eye relief adjustments on the Oculus do seem to, at least on the DK2, do seem to slide around a fair bit. But at least in my experience, I haven't had any issues in terms of continuing legibility or usability from that, at least with these demos.
Yeah, I don't have any problems with that either.
But yeah,
it's been pretty good experience.
Had some problems. Hand over sphere. Then I would check my head left and right. Yeah, we haven't really run into that too much on this, though. One of the kind of the design values that we have when we're working on all of this is that we try and keep all of the tolerances for things as large as possible. And I think that's generally a good call in gesture, and especially in gesture with VR, so that avoiding anything that requires super fine tolerances as best as possible. Just because between the fact that you're dealing with the Oculus, which is still a dev, in development, and you're dealing with gesture, which is kind of inherently can be a little finicky. It's best to try and keep those tolerances large and keep things as simple as possible. Think of it as kind of, if you're used to doing any design for mobile, think of it as kind of mobile tolerances on steroids. In terms of just general design for VR, we've been digging into a lot of that sort of thing recently, and I've been really kind of amazed by how many of the physical affordances and things that we used to try when we were just doing 2D interfaces on the screen that didn't work well. Things like these button presses and pokes, and things like trying to actually pick up items that work amazingly well in VR. So it's really a completely, in the same way that using gesture for the 2D screen is completely different than desktop or mobile design. Really designing for VR is its own can of worms entirely there too, and the usability rules change drastically. So it's an exciting thing to work with.
Yeah, having the depth perception from the VR is really, really great in knowing where your hand is. As opposed to before, we had trying shadows, reflections. Even with that, it was very tough.
Yeah.
So I had a question on the forum some time ago about how to detect hands. I figured that this might be something that many people want to do. For example, if you want to be able to detect a hand entering some space or plane, and you want to figure out which hand it was that entered the space and do something to the hand. So for this example, I will make a basic hand detector and I guess change the hand color as it goes through. So let's go into the right here. I have a trigger box, trigger box collider with a basic hand detector script. Going to mono. And let's see. All right. So, oopsies. Let's put it back down. Okay. So for the one thing, the way the hand controller models work is that at some points, sorry, I was getting very bad. Okay. At some points, that we have a class called a hand model in all of our hands. So the way I do it is looking for that parent. To do that, we have a function called void on trigger enter, collider other, and we have other boolean is hand, collider other, and right here we check if other, sorry, is hand other, then we have hands. And to do that, so the hand model, the hierarchy works like this. We have a hand model, and then we have finger model, and then we have the bone model. So for example, this can be the index, and this can be, I don't know, joint 1, 2, 3. Middle finger, and so on and so forth. This is the structure at which all the hand models work. So following this, how do I comment this? What we can do is we can check to see if the collider object has the hand model. To do that, we do, oh, by the way, sorry, I forgot to mention, all the colliders are in the joint model. They're all in here. So to check if it's the hand, you want to look at the parent's parent, because the colliders are all in the bone model. The finger and the hand model themselves don't have any colliders. So let's just do if other.transform.parent and other. Does the parent just work? No. Other.transform.parent.parent.get component and model. That was very long.
Hey Wilbur, just
Yes.
completely off topic, but
Sure.
a quick question. Are there I know you were doing some stuff about like recording and serializing the incoming leak data.
Yeah.
Is that is the stuff you set up independent of the engine's frame rate, or is that constrained by Unity's frame rate?
When I set it up, it was on the Leap controller's frame rate.
Okay.
So the Unity frame rate and our Leap controller frame rate is not in sync. It could create weird issues where if you're looping through frame per Unity frame, it might look a little bit slow if our frame is really fast, or fast if our frame is very slow.
Okay. And is that all set up in that hand controller where it has the record?
Yes. So I'm not too sure. I have to get back to you on that. I believe Matt Hytel fixed it.
Oh, okay.
But I have to double check with that. I didn't play with it ever since he said he fixed it. But yeah, I'll check with that with you. But then,
Okay,
as
we
far
may
as I
have
know,
to
yeah.
we may have to throw something out about how to do that recording at some point, maybe in the next few weeks.
Yeah, sure. Sounds good.
Yeah. Sorry to just wanted to throw that in there.
Yep. So in here, if I detect as a parent and parent is a parent, and if I get a hand model, I return true. So the reason why I have these checks, for those that don't know, if you don't check if a parent exists, Unity will throw you errors. If you have just this alone, and let's say the parent doesn't exist or the parent's parent doesn't exist, it won't throw you a false, it will just throw you a straight error. So you have to check if the parent itself exists first. And then we call the function, if it's a hand, it will print out there's a hand. Let's go back to Unity. So just so we can see the hand detector, let's put a cube inside it. And let's just make it very small. And no box collider. So I can figure out where it is. Alright, so oopsies, forgot yeah, make sure to bring it up, otherwise it's very hard to see. To around 0.75. Okay. So there you go, hands! As my hand goes through, it detected my hand. So what you can do with this, for example, is maybe you can change all the colors. For example, if it's a hand, let's just do renders. What was the other option? There are better ways of doing this, but I'm just gonna copy this over here. Dot get components children. And for each renders, let's just change all the color to red. Do I have errors? There we go. Awesome. That should work. For each renders. Okay. Not sure why it's still.
Got a semicolon at the end of the other line. There we go.
Thank you.
Yeah.
All right, let's go back.
Real-time code review.
Yeah, I know. Awesome. Render dump 2. Okay, let's go back. Oh, I totally didn't show the model. Sorry. Sorry about that. What I did here was, this is the new thing I added. It's just, I get all the renders of the parent. It looks super ugly. Don't like that part. There are better ways. Instead of having this return a boolean, is hand, you can have it return a game object. And then that game object will reference the whole hand instead. It's better than this little hack here. And I just cycle through all the renders inside this game object and change, or should change, all the color to red. Let's go back to Unity. Okay, so let's play this. Oh no! Didn't get all of them. Oopsies. Something didn't work. Children. Let's just see how many renders there are.
So there's a question here about what are the
Yeah,
exact like millimeter tolerances for mounting the from where we expect the VR mount to be. I don't know those off the top of my head, but I can ask one of our industrial designers what the exact like positioning is, and maybe we can tweet it out on like Leap Motion Developer or something like that.
Yeah.
To see what the exact location is supposed to be for those who want to get that really particular. Just as a note.
Yeah. Should I just try this? Transform dot.
Luckily, we sit right next to the CAD guys, so we can
It's fantastic.
ask them.
That should work, I think. Let's find out. Oh no, it didn't work. I crashed it. Oh, I know the problem. So, be very careful that the collider and the graphics are actually separate as well in this case. You're just gonna crash now. So when the hand spawns two objects, the graphics hand clone and the rigid model clone, I was trying to access the renderer of the rigid hand clone. The rigid hand only has colliders and no graphics.
Right.
So let's go back.
And didn't do the component check.
Yeah, I have to check for that.
Let's make sure that didn't knock out the stream. Oh, no, we're good.
Except I didn't save anything.
Oh no.
Okay. Let's put things back in.
So we're at about a minute left here, so if there's any last second questions that we can help out with, definitely let us know.
Let me just do this.
Finish this one up, and
Yeah.
we're going to be doing another stream next week. So if there's things that you all want to know about, definitely drop us a line, let us know. I think it's going to be on November 11th. Reach out on community.leapmotion or reach out on Twitter and let us know, what sorts of questions you have, what things you'd like to see us cover. We want to be as helpful as possible here. Again, this stuff is going to be getting released out to the community either end of this week or early next week. So you'll be able to jump into these Unity projects and play with these, use these in your own projects, reskin them, all of that. What about Poppable Bubbles Visual Elements? Have you tried that?
So-
Poppable Bubbles. I know we have talked about doing that. I've not personally tried it though. I kind of want to do a VR bubble popper just for the sake of the fact that I think it would be funny.
Yeah.
Wouldn't have haptics in real life too. Yeah, that's a fair point. The fact that you wouldn't expect to get feedback when you actually pop a thing.
Yeah.
Interesting.
I can't do it right off the bat, but it's in our API. The hand model, I believe, should have some access to the graphics, the pairing of it.
Right.
That or I think you might have to access the hand leap controller. The hand leap controller has a graphics and physics kind of a list to all the existing physics and graphics hand.
Right.
What you can do is get the ID of the collider hand, the rigid hand, and then the same ID for the graphics hand would paired with the physics one. So you can do that instead.
Nice.
Yeah, it's sorry this one wasn't as prepared.
Cool. Well, thanks you all for tuning in, and we'll keep doing these, and just let us know your questions for next time. Thanks so much, and have a great day.
Yeah, thank you.
Cheers.